Hello, my name is Kim. I hope you're enjoying an introduction to interactive programming in Python as much as I am. This week, I would like to shine a spotlight on a little math problem: how to solve for n when n is an exponent. The idea for this topic came from reading the mini project description for this week's Guess the Number game. This is the part of the program where we are asked to restrict the player to a certain number of guesses. Specifically, we are asked to allow n guesses where n is the smallest integer such that 2 to the n is greater than or equal to high minus low plus 1. Now, the instructors go on to tell us that when the range is 0 to 100, n is 7, and when the range is 0 to 1000, n is 10. And we could use those numbers in our program, but how did the instructors get those values? They don't really tell us, but they do say that for more of a challenge, we could compute the value of n using math.log and math.ceil from the math module. And really, who could resist a challenge? So here's our equation. Let's try to solve for n using the 0 to 100 range as an example. Max is 100, min is 0, so the right-hand side of the equation can be reduced to 101. That was easy, but now what do we do? So we have n stuck up in the exponent part of the left-hand side of the equation, and we need to get it down so we can isolate it. This is where the log function comes in. We can take the log of both sides of the equation. Now we have log of 2 to the n is greater than or equal to the log of 101. On the left, log of 2 to the n is the same as n times the log of 2. Now, all we have to do is divide both sides by log 2, and we have n greater than or equal to log 101 divided by log 2. Log 101 is about 2, and log 2 is about 0.3. So when we divide those out, we get n is greater than or equal to 6.65. We know n has to be greater than 6.65, and obviously for our project, n has to be an integer, because you can only have a discrete number of guesses. And this is where math.ceil comes in. Think of it as short for ceiling. It takes the next greatest integer higher than the current value. When we do that to 6.65, we get 7, just as the instructors told us. I will let you follow the same steps to prove that when max is 1000 and min is 0, the number of allowed guesses should be 10. And I challenge you, just as the instructors did, to use math.log and math.ceil this week to calculate the number of guesses in your programs. Good luck and have fun.